Hello, welcome to Knowledge of Physics. In this video, I will show you how to find out derivative of the function tan square x from first principle. Please stay connected till the end of this video. If you are new to this channel, please subscribe the channel and also press that bell icon so that you never miss the new updates of this channel. Now let's get it started. Before proceeding the steps of finding the derivative of this function, let me remind you a few standard relations. For example, you have to remember that tan x is expressed in terms of sin and cos x by this relation sin x divided by cos x, and you can also find write cos 2x is equal to 2 times cos square x minus 1, and that is also equal to 1 minus 2 times sin square x. And from this one you can get cos square x is equal to 1 plus cos 2x plus divided by 2, and you know sec square x minus tan square x is equal to 1. And also you know that the relation between cos and sec is sec x is equal to 1 by cos x, or you can say cos x is equal to 1 by sec x. That means sec x times cos x is equal to 1. And in finding derivative of trigonometric function, we have to frequently use this relation, that is cos c minus cos t is equal to 2 times sin of d minus c by 2 times sin of d plus c by 2. Okay, and there is another relation sin 2x is equal to 2 times sin x cos x, and the derivative of x to power n with respect to x is n times x to power n minus 1. And you know the power rule of finding the derivative. That means the derivative of function f of x to power n with respect to x is given by the function derivative of the function f of x to n power n with respect to fx, and you find the derivative of f of x with respect to x, and you multiply these two derivatives and you get the derivative of f of x to power n with respect to x. And you know derivative of tan x is sec square x, and by using this relation we have to find the derivative of tan square x. But this is finding derivative by using the rules of derivative. But in this video I will show you finding the derivative of this tan square x function by using first principle. Now let's proceed the steps. Finding derivative of tan square x from first principle. For that, let's consider y is equal to tan square x, that is equation 1. And we have to consider del x and del y are small increments or small change in x and y. Change in x causes change in y. Then equation 1 in terms of del x and del y can be written as y plus del y is equal to tan square of x plus del x. Let this be equation 2. And subtract equation 1 from equation 2. Then we get del. If you subtract this equation from this, and y plus del y minus y, the y cancels out, then del y, you are left with del y is equal to this term minus this term. So del y is equal to sin square x plus del x minus sin tan square x plus del x minus tan square x. And you have to convert this tan x in terms of sec x, okay, by using this relation. So tan square x here is equal to what you can write it, if you take minus tan square x here on the right hand side, you get tan square x is equal to sec square x minus 1. So we use this relation here, and here use sec square x plus del x minus 1 in place of this tan square x of x plus del x, and you use sec square x minus 1 in place of this tan square x, and this minus makes minus here to plus. So you are left with del y is equal to sec square x plus del x minus 1 minus sec square x plus 1, and 1 cancels out here, and we are left with del y is equal to sec square x plus del x minus sec square x. Now we have to convert this sec into cos. You know cos is equal to 1 by sec, or sec is equal to 1 by cos. So by converting this relay sec to cos, you know del y is equal to 1 divided by cos square plus cos square of x plus del x minus 1 divided by cos square x. Now taking LCM from this denominator, you get cos square x plus cos square x plus del x, and in numerator you are left with cos square x minus cos square x plus del x. Now also convert this cos square x and cos square x plus del x to cos. Okay, here is in the power 2, and we have to make it power 1. Okay, so for that we use this relation, this one. Okay, you have to convert cos square to cos in the term of cos. And here we are left with you can write cos square x is 1 plus cos 2x whole divided by 2, and here cos 2 x plus del x, cos square x plus del x is 1 plus cos square cos 1 plus cos 2 times x plus del x divided by 2, and 1 by 2 1 by 2 1 divided by 2 1 divided by 2 is taken common here, and we are left with del y is equal to 1 by 2 cos 2x plus 1 minus cos 2x plus del x minus 1. This minus makes plus 1 minus 1 here, and the terms factors in denominator is as it is. Now here 1 cancels out, and 1 by 2 is there, and we are left with cos 2x minus cos 2x plus del x on numerator, and you can see the so del y is equal to 1 by 2, and you have to use here the formula cos c minus cos d. I have also shown you here this relation. Okay, cos c minus cos d is equal to 2 times sine of d minus c by 2 times sine of d plus 2 d plus c by 2. We have to use this relation on this step here, and the difference is c means 2x and d means 2 times x plus del x. Using that relation we have 2 times sine of 2x plus 2 times del x minus 2x divided by 2 times sine of 2x plus 2 del x plus 2x divided by 2 whole divided by cos square x times cos square x plus del x is there. Now here what we are left with is del y is equal to here 2 cancels out, and here inside this sign there is 2x and minus 2x, so this 2x and 2x cancel out, and this 2 also cancel this 2, so we are left here sine of del x, and here 2x plus 2x becomes 4x, and plus 2 del x is there, this 2 commons 4 and 2, and we are left with sine of 2x plus del x here, and on denominator cos square x plus del x. These two factors are as it were there. Okay, now next step what we have to do is we have to divide the last equation by del x, and by dividing by del x on both sides we get del y by del x is equal to sine of del x times sine of 2x plus del x whole divided by del x times cos square 2x plus del x. Now taking limit as limit del x tends to 0 on both sides of this equation, then we get limit del x tends to 0, del y by del x is equal to limit del x tends to 0, and this term on right hand side. Okay, now from first principle of derivative what we have got is limit del x tends to 0, del y by del x is equal to dy by dx. This means derivative of the function y with respect to x. Y is function of x, and that is equal to limit del x tends to 0, limit sine del x times sine 2x plus del x, and on denominator there is del x times cos square x times cos square x plus del x, and this cos square x is independent of this del x. You can take it out from limit, and you can use del x 0 inside this cos, so we are left with sine, and you can also use del x here. Okay, these factors does not give you, these factors do not make this term indeterminate form, so we take it out from the limit. So dy by dx is equal to sine of 2x plus 0 divided by cos 2x times cos square x times cos square x plus 0, and limit del x tends to 0, inside limit we are left with the sine of del x divided by del x. And but from standard relation what we have got is limit of del sine of del x divided by del x as del x tends to 0 is equal to 1, And if we use this relation here, we are left with dy by dx is equal to sine 2x divided by cos square x times cos square x into, and here there is 1. Now here we have to use some standard relations. Dy by dx is equal to, sine 2x means 2 sine x cos x, and there is cos square x, and one of this cos square x and cos square x is cancelled out by this cos here, and so we are left with dy by dx is equal to 2 times sine x divided by cos x cos square x, and 2 times sine x divided by cos x gives you 2 times tan x, and 1 by cos square x means this is sec square x. This is the derivative of y, that is tan square x with respect to x from first principle. Therefore d by dx tan square x is equal to 2 times tan x sec square x. Let's this be equation 1. So let's this be equation 3. Okay, equation 3 represents the derivative of tan square x derived from first principle, and here I have here, okay, derivative of tan square x with respect to x, that is given as d of tan square x by divided by dx times d tan x by dx is equal to, we have got it, 2 times tan x times sec square x. By using this power rule, you can also find it out from there. So here this is the same step as I have already told you. So derivative of tan square x with respect to x is 2 times tan x sec square x. This relation is used by using the power rule. And here please add d before this tan square x here, okay. Now I found many students who are confused of using chain rule and power rule, okay. So I have already told you power rule is used in such a situation where you are provided the function as a function with its power n or any other integers. So here the function is power rule means the derivative of the function f of x with a power n with respect to x, and to find the derivative of this function f of x to power n, what you have to do is you have to find the derivative of this f of x to power n with respect to f of x, and you also find the derivative of f of x with respect to x and multiply these two factors so that you get the derivative of f of x to power n with respect to x. This is power rule, okay. Power rule means you are provided the function with a power n. But in case of chain rule, there is a little bit different case. In chain rule, what you may be given is there can be many functions. For example, y is function of u is function of v, and v is function of x. So ultimately y is function of x, but x is not directly related to y. First of all, x is related to v, and v is related to u, and u is related to y, okay. So if we have to find derivative of y with respect to x, we have to use here chain rule. How? Let me show you. The derivative of y with respect to x is dy by dx. What we have done here is we first of all find out the derivative of y with respect to u, okay, this factor, derivative of y with respect to u, okay, and then we have to find out the derivative of u with respect to v. The variable of y is u, the variable of u is v, and variable of v is x. So first of all we found out derivative of y with respect to its variable u, okay, and then we have to find out derivative of u with respect to its variable v, and then we have to find out derivative of v with respect to its variable x, and multiply these three factors so that we get the derivative of y with respect to x. If you are asked to find the derivative of u with respect to v, then what you have to do is you have to find out only these two factors, derivative of y with respect to u and derivative of u with respect to v, and there dy by dv there must be, okay. So dy by dv is equal to dy by du multiplied by du by dv. But in this case, you are asked to find the derivative of y with respect to x, so we have to find out this dv by dx as well. And after multiplying out these three factors, we get dy by dx. This is derivative of y with respect to x, and this rule is called as chain rule. There are a chain of derivatives, so it is called chain rule. Okay, to find out, you can find out here the line. To find out derivative of first function means y with respect to last variable means x. Okay, actually direct variable of y with respect to direct variable of y is u. Okay, and direct variable of u is v, and direct variable of v is x. So we have to find out the derivative of y with respect to last variable x. So for finding out this derivative, what we have to do is find derivatives of each function with respect to its variable. It means derivative of function y with respect to its variable u, derivative of function u with respect to its variable v, and derivative of function v with respect to its variable x, and then multiply all derivatives to get derivative of first function with respect to last variable. Then we have to multiply all derivatives to find out the derivative of first function means y with respect to the last variable, that means x. So dy by dx is equal to this term. Okay, let me show you an example. This is an example of using chain rule to find out the derivative of given function. So here you are given with a function as exponential log of tan root under x with respect to x. We have to find the derivative of this given function with respect to x. So what we have to do here is finding the derivative of this function with respect to x. But this function is not directly related to x, it is indirectly related to x. The first function is exponential, then is a log and tan, and the variable, and the function is root x, and the last variable is x. First of all, the function is exponential x, and it is log, and then tan and root x and x. You can also say here we have used here y u v. Okay, so you can consider here this exponential functions mean it is y. Okay, and this log functions mean u, and tan means v, and root x means actually x, but in this case there are 1 2 3 4 functions. One is exponential, another is log, another is tan, and also square root, and the variable is x, last variable. So if you have to find the derivative of this function with respect to x, what you have to do is find out the function of derivative of this whole function exponential log x, log tan root x with respect to log tan root x. Actually the variable of this exponential function is log tan root x. Okay, and then you have to find out the derivative of this log tan root x with respect to tan root x, and then we have to find derivative of tan root x with respect to root x, and then you have to find the derivative of root x with respect to dx with respect to x. Okay, after finding all these derivatives, we have to multiply these factors. Okay, and after multiplying, what we get is this function derivative of this term is actually exponential log tan root x, and derivative of log tan root x with respect to tan root x is 1 by tan root x, and derivative of tan root x with respect to root x is sec square root x, and derivative of root x with respect to x is 1 by 2 x to power minus half 1 by 2. And after simple simplification, we get derivative of exponential given function exponential log tan root x with respect to x is equal to exponential log tan root x sec square root x divided by tan root x times 1 by 2 root x. In this way, you can use the chain rule to find out the derivative of given function. I hope this concept is clear now. It will help you to find out the derivative of any function by using the chain rule or power rule. Thank you so much for watching. We will catch you in next video. Till then, stay connected with us by subscribing the channel. Thank you so much. You can also share this video with your friends.